Lake Michigan does not look dangerous at first glance. On calm days, the water stretches out like a sheet of glass, blue and quiet, bordered by long beaches and familiar shorelines. But beneath that calm surface lies one of the largest underwater graveyards in North America. For more than 3 centuries, ships have vanished here. Some were wooden cargo vessels moving grain and timber. Others carried families, workers, or entire communities across the inland seas. Many never reached the other side. Sailors learned early that Lake Michigan behaves less like a lake and more like an ocean. Storms rise fast, without warning. Winds shift direction in minutes. Waves grow tall and steep, packed tightly together, slamming ships again and again without pause. In the 1800s, before modern forecasts, captains often had no idea what they were sailing into. By the time they realized, it was usually too late. The first recorded shipwrecks on Lake Michigan date back to the late 1700s, when European trade routes expanded across the Great Lakes. Wooden ships carried fur, iron, coal, and lumber between growing frontier towns. These vessels were strong for their time, but the lake tested them relentlessly. Ice crushed hulls in winter. Sudden squalls snapped masts. Poor charts led ships straight into shallow reefs and sandbars hidden just below the surface. As traffic increased, so did the losses. By the mid-19th century, Lake Michigan had already claimed hundreds of vessels. Newspapers regularly reported ships that simply failed to arrive. Sometimes debris washed ashore days later. Other times there was nothing at all. Families waited, hoping for word, until hope quietly faded into routine grief. One of the reasons Lake Michigan became such a deadly place is its geography. The lake is long and narrow, which allows wind to travel uninterrupted across great distances. When strong systems move in from the plains, the water has nowhere to release that energy. Waves stack up instead of spreading out. Sailors described storms where the lake seemed to rise straight upward, turning into walls of water rather than rolling swells. Temperature made things worse. Lake Michigan stays cold even in summer. When ships sank, survival time in the water was short. In many cases, crews had minutes, not hours. This is why so many wrecks are tied to sudden storms. The ships did not always break apart slowly. Some were overwhelmed in a single night. The wreck of the Lady Elgin in 1860 is one of the most tragic examples. Carrying hundreds of passengers from Milwaukee to Chicago, the ship collided with another vessel during a storm. Within an hour, it sank. Over 300 people died. Many bodies were never recovered. At the time, it was one of the deadliest maritime disasters on the Great Lakes, and it forced new conversations about safety, navigation rules, and ship construction. Yet disasters continued. In 1871, the Peshtigo fire burned entire towns along the western shore, while ships offshore watched helplessly as the horizon glowed red. Some vessels were damaged by falling embers. Others carried survivors away from the flames, only to be lost later to storms. The lake seemed to collect tragedy from every direction. What makes Lake Michigan's shipwrecks especially important today is how well they are preserved. Unlike saltwater oceans, the lake contains very little salt and almost no ship-eating organisms. Wood does not rot the same way. Iron corrodes more slowly. As a result, many wrecks rest on the lake bed almost exactly as they sank. Divers who descend to these sites often describe the experience as stepping into a paused moment. Wheels remain attached. Cabins are still furnished. Cargo lies undisturbed. In some wrecks, dishes are stacked in galleys and shoes sit where someone once left them. It is underwater archaeology in its most haunting form, not because of fear but because of how close it feels. Over time, these wrecks turned Lake Michigan into a living museum. More than 1,500 shipwrecks have been documented, and experts believe many more remain undiscovered. Some lie in shallow water, known to fishermen and divers for generations. Others rest in deep, dark zones far from shore, unreachable without advanced equipment. Finding them has always been difficult. Early searches relied on eyewitness accounts and rough maps. Later, divers scanned likely areas slowly, meter by meter. Progress was slow until sonar changed everything. Side-scan sonar allowed researchers to send sound waves across the lake bed, creating detailed images of shapes below. Shipwrecks suddenly stood out as shadows and outlines against flat sediment. What no one expected was that sonar would reveal more than just ships. As mapping expanded, researchers began noticing shapes that did not match known wrecks. Lines too straight, circles too precise, stones arranged in ways that did not fit natural patterns. These findings were often dismissed at first. Sonar images can be misleading. Rocks can trick the eye. But some formations appeared again and again, consistent and deliberate. This is where shipwreck exploration and ancient archaeology quietly crossed paths. The same technology used to locate sunken schooners began uncovering structures that seemed much older than recorded shipping history. In some cases, these shapes appeared near known wreck sites, simply because those areas had been mapped more thoroughly. What began as a search for lost ships slowly expanded into a deeper question about what the lake was hiding. Lake Michigan was not always a lake. During the last ice age, water levels were far lower. Large areas of the current lake bed were once dry land. People lived there. They hunted, traveled, and built stone structures long before the water rose. When glaciers melted and the basin filled, those landscapes disappeared underwater, preserved in silence. For shipwreck hunters, this realization changed the meaning of every scan. A sonar image was no longer just a possible wreck. It could be a trail, a hunting structure, or a ceremonial site. The lake was no longer only a graveyard for ships. It was also a flooded archive of human history. By the early 2000s, researchers working in northern Lake Michigan encountered something that pushed this idea further. Amid familiar wreck targets, they found a circular stone arrangement unlike any ship debris. Nearby, a carved stone appeared to show the shape of a mastodon, an animal that vanished thousands of years before the first European ship ever sailed these waters. These discoveries did not erase the shipwrecks. Instead, they placed them into a much longer story. Every wreck now rests atop older layers of loss, memory, and time. The lake bed holds centuries stacked on top of millennia, each era leaving its mark. When sonar mapping became common in the Great Lakes, it quietly changed how Lake Michigan was understood. Before that, much of the lake's history depended on written records and survivor accounts. Ships that vanished without witnesses were often assumed lost forever. Sonar made absence visible. It turned empty stretches of water into readable landscapes, revealing outlines that had been hidden for generations. Sidescan sonar works by sending sound waves outward from a vessel and recording how they bounce back. Hard objects return strong signals. Soft sediment absorbs sound. On the screen, wrecks appear as long shadows with sharp edges, clearly separated from the smooth lake bed. At first, researchers focused only on shapes that matched known ships. Over time, as scans became more detailed, other patterns began to stand out. One of the most famous sonar discoveries in Lake Michigan is the wreck of the Rouse Simmons, known as the Christmas Tree Ship. In November 1912, the wooden schooner left Michigan's Upper Peninsula loaded with Christmas trees, heading toward Chicago. A storm struck and the ship never arrived. For decades, its fate was unknown. Families passed down stories. Historians debated its route. In 1971, the wreck was finally found resting upright on the lake bed, remarkably intact. The trees were still tied to the deck. The discovery was not dramatic or sudden. It came from careful sonar work, patience, and a willingness to search places others had overlooked. It became a model for how lost ships could be found, not through luck, but through methodical mapping. Other wrecks soon followed. The Wisconsin, a passenger ship that burned and sank in 1929. The Lady Elgin, broken into pieces but still identifiable. The Seabird, found sitting upright with its lifeboat missing, creating the illusion of an abandoned ship rather than a wreck. Each discovery added detail to the lake's story and proved how much was still waiting below. As sonar surveys expanded, researchers began to notice something unusual. In areas with no recorded ship losses, shapes still appeared. They were not long and narrow like hulls. They lacked debris fields. Some were clusters of stones arranged in lines. Others formed curves that repeated too cleanly to ignore. At first, these shapes were marked and set aside. The focus remained on ships. But curiosity lingered. In underwater archaeology, context matters. A shipwreck usually carries cargo, anchors, or structural elements. These formations did not. They looked older, simpler, more intentional in a different way. This is where the boundary between maritime history and ancient history blurred. Shipwreck hunters found themselves consulting geologists and archaeologists. Questions shifted from "what ship is this?" to "what landscape are we seeing?" The lakebed was no longer just a place where ships ended. It was a place where people once lived. One of the challenges in Lake Michigan is depth. Many wrecks sit beyond recreational diving limits. At those depths, light fades quickly. Cold sets in. Human presence becomes brief and costly. This is why sonar remains essential. It allows researchers to see without disturbing. But sonar does not explain purpose. It only shows shape. To understand those shapes, scientists had to look backward in time. During the last ice age, around 12,000 years ago, glaciers covered much of the region. As they retreated, massive meltwater lakes formed and drained repeatedly. Water levels rose and fell over centuries. Areas that are now hundreds of feet underwater were once plains, ridges, and valleys. Archaeological evidence shows that humans followed these changing landscapes. They hunted caribou along ice margins. They traveled seasonal routes. In nearby Lake Huron, researchers found stone hunting structures submerged beneath the water. These were not accidental piles of rock. They were carefully placed drive lanes used to guide animals toward hunters. That discovery changed expectations across the Great Lakes. If such structures existed in Lake Huron, there was no reason to assume Lake Michigan was different. The same people lived there. The same environmental changes occurred. The only difference was how little of it had been explored. The overlap became clear during joint expeditions. Sonar teams searching for wrecks began coordinating with archaeologists studying submerged landscapes. Each group brought different questions but the same tools. Shipwreck data helped refine maps. Ancient features helped explain unusual sonar returns. Together they started to see the lake as layered rather than singular. This layered view also changed how shipwrecks themselves were understood. Many wrecks lie on ancient shorelines. Some rest near submerged river channels. Their final resting places are tied not just to storms, but to older geography hidden beneath the water. A ship that ran aground in the 1800s may have struck a ridge formed thousands of years earlier. Preservation plays a quiet role in all of this. Cold fresh water slows decay, but it also freezes time. Wrecks do not scatter the way they might in oceans. Ancient stone structures remain sharp-edged instead of eroded smooth. This makes interpretation harder, not easier. Natural and human-made features can look similar when both are well preserved. That uncertainty defines much of Lake Michigan's underwater archaeology. Researchers are careful with language. They avoid quick conclusions. A structure may be described as possibly cultural rather than built. A carving may be labeled suggestive rather than confirmed. This caution frustrates the public, but it reflects the limits of evidence. Still, the pattern is hard to ignore. The more the lake is mapped, the more it reveals. Each new wreck leads to wider surveys. Each survey uncovers anomalies. The lake's reputation as a ship graveyard remains accurate, but incomplete. It is also a record of landscapes erased, preserved beneath centuries of water. By this point, Lake Michigan can no longer be seen as just a place of accidents and storms. It is a convergence zone, where recent history rests directly on top of deep time. To understand one, researchers must acknowledge the other. Shipwrecks opened the door. Ancient structures quietly waited beyond it. As sonar images of Lake Michigan became more detailed, certain areas began to attract repeated attention. These were not places tied to famous storms or known shipping routes. Instead, they were stretches of the lakebed that showed patterns no one could easily explain. Lines appeared where random scatter was expected. Stones formed curves instead of chaotic clusters. Each pass of the sonar returned the same results, as if the lake was quietly insisting on being noticed. One of these areas lies in the northern part of Lake Michigan, near the waters between Wisconsin and Michigan's Upper Peninsula. Researchers were not looking for ancient sites there. They were mapping shipwrecks, filling in gaps left by earlier surveys. But among the familiar outlines of sunken hulls, something else stood out. The sonar showed a ring of large stones arranged in a loose circle. It was not perfectly symmetrical, but it was clearly organized. Each stone was separated by a similar distance. The formation did not resemble a wreck, debris field, or natural rock slide. It looked deliberate. More importantly, it looked old. When divers later examined the site using remotely operated vehicles and limited dives, the formation remained consistent with the sonar data. The stones were too large to have been moved easily by ice or currents. The surrounding sediment suggested long-term stability rather than recent disturbance. There was no sign of modern activity. Nearby, another object drew attention. A single stone bore markings that appeared to form the shape of a mastodon. The carving showed a curved back, a downward sloping head, and what looked like tusks. Mastodons roamed the Great Lakes region more than 10,000 years ago, long before Lake Michigan reached its current level. The carving was not sharp or decorative. It was simple, almost rough. But that simplicity made it harder to dismiss. Ice scratches do not usually form recognizable animals. Natural fractures rarely repeat familiar shapes so clearly. Still, researchers were cautious. Underwater imagery can deceive. Lighting, shadows, and angles can create illusions. Experts from different fields examined the data. Geologists studied the stone's composition and fracture patterns. Archaeologists compared the shape to known prehistoric carvings. Indigenous historians considered whether similar imagery appeared in regional oral traditions. No single discipline could answer the question alone. Dating the site proved to be the greatest challenge. Stone itself cannot be directly dated unless organic material is attached. No wood, bone, or tools were found near the circle or carving. Without that, scientists could not assign a firm age. They could only estimate based on lake-level history. Geological studies show that the area where the stones rest would have been dry land more than 9,000 years ago. If humans placed those stones, it would have been during a time when mastodons still lived nearby. That possibility does not violate known timelines, but it pushes against older assumptions about human activity in the region. For much of the 20th century, mainstream archaeology placed early North American cultures primarily on land, moving slowly and leaving few structures behind. Submerged archaeology challenges that view. It suggests that early people may have built more than camps and tool sites. They may have shaped landscapes in ways that water later erased. The stone circle does not stand alone. Similar underwater stone features have been documented in nearby Great Lakes, especially Lake Huron. There, researchers found hunting structures made from carefully arranged stones, used to guide caribou toward ambush points. These sites are widely accepted as human-made. The Lake Michigan Formation shares certain traits with those structures, such as stone size and placement strategy. What differs is shape. A circle implies gathering, marking, or ceremony rather than hunting. That difference makes interpretation harder. Few known Ice Age structures in North America resemble stone circles. This is where caution becomes essential. Scientists resist labeling the formation as ceremonial without clear evidence. Natural processes can arrange stones in surprising ways, especially over thousands of years. Glacial movement, ice rafting, and freeze-thaw cycles can all reposition rocks. Yet those processes tend to leave chaotic patterns. The Lake Michigan stones show order. That order is what keeps the debate alive. Funding limitations slow progress. Freshwater archaeology receives far less attention than ocean exploration. Research vessels are expensive. Diving seasons are short. Each expedition requires permits, coordination with state authorities, and respect for indigenous interests. As a result, the site has been documented but not exhaustively studied. High-resolution mapping remains incomplete. Direct excavation has not occurred. The carving, in particular, remains controversial because it has not been physically recovered or closely analyzed in a laboratory. This uncertainty frustrates some observers, but it also protects the site. Without public access or clear conclusions, the stones remain undisturbed. They rest in darkness, unchanged, waiting for future technology and research priorities to catch up. What matters most is not whether the formation is eventually proven human-made. What matters is what it represents. It shows that Lake Michigan is not just a container for wrecks. It is a layered archive where different eras overlap. Shipwrecks rest on top of ancient shorelines. Modern sonar reveals both at once. The lake's reputation as a graveyard extends beyond ships. It is also a resting place for forgotten landscapes and lost chapters of human history. As researchers continue to map the lake, they are no longer surprised when they find something unexpected. They expect it. Each scan carries the possibility of another wreck, another structure, another question. The lake has taught them to be patient. Despite everything that has been found so far, Lake Michigan remains largely unexplored. This is not because of a lack of interest but because of limits, legal, financial, and practical, that shape what can be studied and how far research can go. The lake may sit at the center of a populated region, but beneath the surface, it is still one of North America's least understood archaeological spaces. One major reason is jurisdiction. Lake Michigan touches 4 U.S. states, and each has its own laws about submerged cultural resources. Shipwrecks are often protected as historical sites, but ancient structures fall into a gray area. It is not always clear who has authority over them, or how they should be classified. Are they archaeological sites, natural features, or something else entirely? Without clear definitions, research moves slowly. Indigenous rights add another important layer. Many tribes consider submerged landscapes part of their ancestral homeland. Any study of ancient underwater sites requires consultation, consent, and respect for oral histories that may not align neatly with Western archaeological models. This is not a barrier so much as a responsibility, but it does affect timelines and methods. Funding is another obstacle. Most underwater archaeology funding goes to ocean-based projects, often tied to shipwrecks of global interest or deep-sea exploration. Freshwater research struggles to compete. Lake Michigan does not carry the same romantic image as the open ocean, even though its discoveries may be just as important. Because of this, much of the work is done by small teams, universities, or nonprofit groups. Expeditions are brief. Equipment is shared. Data collection happens in stages, sometimes spread across many years. Progress is careful and slow by necessity. Technology continues to improve, but access remains limited. High-resolution sonar, autonomous underwater vehicles, and advanced mapping tools are expensive. When they are used, priorities must be set. Known wreck sites often take precedence because they are easier to justify and protect. This means ancient features, especially those without clear identification, remain in limbo. They are documented enough to raise questions but not enough to answer them. The Lake Michigan Stone Circle exists in this space. It is known, mapped, and debated but not fully understood. Shipwrecks, by contrast, are more straightforward. A wreck has a name, a date, and a story tied to human records. It fits comfortably into history. Ancient submerged sites challenge that comfort. They suggest that parts of history were written on landscapes that no longer exist above water. What makes Lake Michigan unique is how clearly these layers overlap. A 19th-century schooner may rest just meters away from a structure thousands of years older. Sonar does not distinguish between eras. It reveals everything at once, forcing researchers to think across time instead of within it. This layered reality changes how the lake is perceived. It is no longer only a place where ships met bad weather. It is a place where climate change, human movement, and geological forces intersected repeatedly. Each rise in water level erased part of the story, but also preserved it. The shipwrecks drew attention first because they were dramatic and visible. They told stories of loss that could be traced through newspapers and family records. But in doing so, they opened the door to deeper questions. Why did these routes exist? What did the lake look like before ships crossed it? Who lived here before the water rose? Those questions are now part of underwater archaeology, even if the answers remain incomplete. Researchers no longer scan the lake bed expecting only wrecks. They expect complexity. They expect surprises. Lake Michigan's reputation as a ship graveyard is accurate, but it is only one layer of the truth. Beneath the wrecks lies a much older graveyard of landscapes, paths, and possibly structures that once stood in open air. Together, they form a continuous record of human interaction with a changing environment. The stone circle and mastodon carving may one day be explained clearly. They may be proven natural or confirmed as human-made. Either outcome will matter less than the process that led there. That process has already expanded the boundaries of what underwater archaeology considers possible in freshwater environments. For now, the lake keeps its balance. It reveals enough to invite study, but not enough to settle every debate. Shipwrecks remain its most visible legacy, drawing divers, historians, and explorers year after year. Yet beneath those familiar silhouettes lies a quieter history, older and harder to read. Understanding Lake Michigan means accepting both stories at once. The ships that never made it home. And the people who lived here long before any ship ever sailed.